Now, in the Nernst equation video, where we go through an example problem, we see that we can do a calculation for these concentrations in this system. We get these half cell potentials, and we total it up to find out that the energy of the cell is 1.242 volts. Now, there are two different ways that we could do that. We could either handle the sign change just by having the energy of the right side minus energy of the left side, or we handle the sign change by saying, let's solve it for the reverse reaction. In other words, we're going to change the sign on the anodic side, and then we're just going to add the two values together. Both ways give you the same result. But here's an extra way that we can visualize that, and it works with a number line. And that's something I think is a very good way to double check where you're actually at. Now notice that here, what we're going to do is we're just going to calculate each of these values, and we're going to specify that we're starting with the cation and going to the neutral. In other words, we're staying with our reduction potentials right here. So these aren't standard reductions, these are our calculated reductions. So our reduction potential for this side would be negative 0.461 volts. This one would be positive 0.781 volts. And when we think about how far away those two will be from each other, we say that our cell voltage will be 1.242 volts. Now, if you do a number line like this to handle combining these two electrodes, I think that it's a pretty powerful way because it matches the exact same convention we have up here in our sketch for the cell. We start out with all of our anodic side over here. Our electrons are passing this direction just like they are on the sketch. Now, the only difference is if you want to think through it the way that we would for our cell, we start out with our cation, the electrons going into the metal's passing the electrons along to the other side, and then we just have to kind of say it goes to this side and then goes inward. So it's kind of like we're doing outside toward inside, outside toward inside. So that's a good way that you can do this graphically. Now obviously you still have to calculate your individual half cell potentials, but this is a great way to keep yourself from ending up with a sign error happening right here in the middle. So I recommend using both the numeric and the graphic way simultaneously to make sure you're constantly getting correct answers. So make sure you practice some of these visualizations of cell potentials and also your calculations of them.